National Electrical Code Section 406.5c mandates a specific orientation for receptacle installation. This regulation stipulates that receptacles must be installed with the grounding terminal facing either upwards or downwards. The reasoning behind this code requirement centers on electrical safety. The intended orientation ensures that, in the event of a plug being accidentally or forcefully removed from the receptacle, the grounding prong of the plug will establish contact with the grounding terminal of the receptacle before the live, or current-carrying, terminals make contact. This sequence of contact is crucial for preventing electrical shock hazards. By ensuring that the grounding connection is established first, any potential fault current is safely directed to ground, minimizing the risk of electric shock to individuals who might be in contact with the electrical system or equipment. The consequences of violating National Electrical Code Section 406.5c extend beyond mere code non-compliance. Firstly, and most critically, misaligned receptacles pose a significant electrical shock hazard. If a plug is partially pulled out, the exposed live terminals can create a pathway for electricity to flow through a person, resulting in serious injury or even death. Secondly, failure to comply with National Electrical Code regulations can lead to the failure of electrical inspections. During routine or mandated electrical inspections, improperly oriented receptacles will be flagged as a violation, requiring corrective action to bring the installation into compliance. Thirdly, non-compliance with National Electrical Code standards can have implications for insurance coverage. In the unfortunate event of an electrical accident, insurance companies may deny coverage if it is determined that the accident was caused by a code violation such as misaligned receptacles. To rectify this code violation and mitigate the associated safety risks, it is strongly recommended to correct the orientation of the receptacles immediately. This task should be performed by a qualified electrician who possesses the knowledge, skills, and experience to safely and effectively work with electrical systems. The electrician will carefully disconnect the power supply to the receptacle, reorient the device to comply with National Electrical Code Section 406.5c, and ensure that all connections are secure and properly insulated. Proper grounding is a critical safety feature in electrical systems. It provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter and interrupting the flow of electricity. This protects people from electric shock and prevents damage to equipment. Receptacles are typically grounded through a grounding wire that connects the grounding terminal of the receptacle to the electrical panel. The electrical panel is then grounded to the earth through a grounding electrode system. This system typically consists of a ground rod or a metal water pipe that is buried in the ground. The purpose of the grounding electrode system is to provide a low resistance path for fault current to flow to the earth. The National Electrical Code provides specific requirements for grounding electrical systems. These requirements are designed to ensure that electrical systems are safely grounded and that people are protected from electric shock. Ground fault circuit interrupters are another important safety device that can help to prevent electric shock. Ground fault circuit interrupters are designed to detect small amounts of current leakage to ground. When a ground fault is detected, the ground fault circuit interrupter will quickly trip the circuit, interrupting the flow of electricity. Ground fault circuit interrupters are commonly used in bathrooms, kitchens, and other areas where there is a risk of electric shock. Electrical safety is a critical aspect of homeownership and should never be taken lightly. Understanding and adhering to National Electrical Code regulations, such as the requirement for proper receptacle orientation, is essential for ensuring the safety of your home and its occupants. If you have any concerns about the electrical system in your home, it is always best to consult with a qualified electrician. Electrical systems operate on several fundamental principles. Firstly, there is voltage, which is the electrical potential difference or pressure that drives the flow of electrical current in a circuit. It's measured in volts. Common voltage levels in residential settings are 120 volts for standard outlets and lighting and 240 volts for larger appliances like dryers and ovens. Secondly, there's current, which is the rate of flow of electrical charge through a conductor. It's measured in amps. The amount of current drawn by an appliance or device depends on its power rating. Circuit breakers are designed to protect circuits from overcurrents, which can cause overheating and fires. Thirdly, resistance is the opposition to the flow of electrical current in a circuit. It's measured in ohms. Resistance depends on the material and physical properties of the conductor. Higher resistance leads to greater energy dissipation in the form of heat. Ohm's law describes the relationship between voltage, current, and resistance. Voltage equals current times resistance. Electrical power is the rate at which electrical energy is transferred or consumed in a circuit. It's measured in watts. Power is calculated as voltage times current. Appliances and devices are labeled with their power consumption in watts. Understanding these fundamental principles is essential for comprehending how electrical systems function and for ensuring electrical safety. Electrical circuits are pathways that allow electrical current to flow from a power source to a load and back. They typically consist of conductors, such as wires, connected to a voltage source, such as an electrical panel, and a load, such as a light bulb or appliance. There are three main types of electrical circuits: series circuits, parallel circuits, and series parallel circuits. In a series circuit, components are connected end to end, so the same current flows through each component. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the voltage across each component is the same. The total current in a parallel circuit is the sum of the individual currents. In a series parallel circuit, some components are connected in series, while others are connected in parallel. Understanding the different types of electrical circuits is important for troubleshooting electrical problems and for designing new electrical systems. Electrical panels, also known as breaker boxes or load centers, are distribution points for electrical power in a building. They receive power from the utility company and distribute it to individual circuits throughout the building. Electrical panels contain circuit breakers, which are protective devices that automatically interrupt the flow of electricity in a circuit if an overcurrent or short circuit occurs. Circuit breakers are rated in amps, indicating the maximum current they can safely carry. The size of the circuit breaker should be matched to the size of the wiring in the circuit. Electrical panels also contain a grounding busbar, which is a conductive bar that connects the grounding wires from all the circuits in the building to the grounding electrode system. Proper grounding is essential for electrical safety. When working with electrical panels, it's important to follow safety precautions such as wearing insulated gloves and eye protection, and to turn off the power to the panel before working on any of the components. Wiring is the network of conductors that carries electrical current throughout a building. Wires are typically made of copper or aluminum and are insulated with a plastic or rubber coating. The size of the wiring depends on the amount of current it needs to carry. The National Electrical Code provides specific requirements for wiring sizes based on the ampacity of the circuit. Wiring is typically run through walls, ceilings, and floors in conduit or cable. Conduit is a rigid metal or plastic tube that protects the wiring from damage. Cable is a flexible assembly of wires that are enclosed in a protective sheath. When working with wiring, it's important to follow safety precautions such as turning off the power to the circuit before working on any of the wires, and to use the proper tools and techniques. Receptacles, also known as outlets, are points where electrical power can be accessed to power appliances and devices. Receptacles typically have 2 or 3 slots. The 2 slots are for the hot and neutral wires, and the 3rd slot is for the grounding wire. The hot wire carries the electrical current from the power source to the appliance or device. The neutral wire carries the electrical current back to the power source. The grounding wire provides a path for fault current to flow back to the power source, tripping a circuit breaker or ground fault circuit interrupter and interrupting the flow of electricity. Receptacles are rated in amps, indicating the maximum current they can safely carry. The rating of the receptacle should be matched to the size of the wiring in the circuit. When installing receptacles, it's important to follow safety precautions such as turning off the power to the circuit before working on any of the wires, and to use the proper tools and techniques. Lighting is an essential part of any building. providing illumination for various activities. Lighting fixtures come in a variety of styles and types, including incandescent, fluorescent, light-emitting diode, and halogen. Incandescent lamps are the traditional type of light bulb, but they are less energy efficient than other types of lamps. Fluorescent lamps are more energy efficient than incandescent lamps, but they contain mercury, which is a hazardous material. Light-emitting diode lamps are the most energy efficient type of lamp, and they do not contain mercury. Halogen lamps are similar to incandescent lamps, but they are more energy efficient and have a longer lifespan. Lighting circuits are typically wired with 14 or 12 gauge wire, depending on the ampacity of the circuit. Lighting circuits should be protected by a circuit breaker that is sized appropriately for the wiring. When installing lighting fixtures, it's important to follow safety precautions such as turning off the power to the circuit before working on any of the wires, and to use the proper tools and techniques. Electrical safety is paramount when working with any electrical system or component. It's crucial to understand the potential hazards involved and to take the necessary precautions to prevent accidents. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and equipment to avoid contact with live wires. Wear appropriate personal protective equipment, such as insulated gloves and eye protection. Never work on electrical systems in wet or damp conditions. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Brand fault circuit interrupters are an important safety device that can help to prevent electric shock. Brand fault circuit interrupters are designed to detect small amounts of current leakage to ground. When a ground fault is detected, the ground fault circuit interrupter will quickly trip the circuit, interrupting the flow of electricity. Ground fault circuit interrupters are commonly used in bathrooms, kitchens, and other areas where there is a risk of electric shock. Arc fault circuit interrupters are another important safety device that can help to prevent electrical fires. Arc fault circuit interrupters are designed to detect arc faults, which are dangerous electrical discharges that can occur when wires become frayed or damaged. When an arc fault is detected, the arc fault circuit interrupter will quickly trip the circuit, interrupting the flow of electricity and preventing a fire. The National Electrical Code provides specific requirements for electrical installations. These requirements are designed to ensure that electrical systems are safely installed and that people are protected from electrical hazards. It's important to be familiar with the National Electrical Code requirements and to follow them carefully when working with electrical systems. If you have any questions about electrical safety or the National Electrical Code, consult with a qualified electrician. Electrical codes and standards are sets of rules and guidelines that govern the design, installation, and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, which publishes the National Electrical Code, and Underwriters Laboratories, which tests and certifies electrical products. The purpose of electrical codes and standards is to ensure that electrical systems are safe and reliable and that they meet certain performance requirements. Electrical codes and standards cover a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. They are constantly updated to reflect new technologies and to address emerging safety concerns. Compliance with electrical codes and standards is typically required by law, and it's essential for ensuring the safety of people and property. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations comply with applicable codes and standards. Electrical inspections are typically required for new construction, renovations, and repairs. The purpose of an electrical inspection is to identify any potential safety hazards and to ensure that the electrical system is installed correctly. Electrical inspectors will typically check the wiring, grounding, overcurrent protection, and equipment installation to ensure that they meet the requirements of the electrical code. If any violations are found, the electrical inspector will issue a notice of violation, which must be corrected before the electrical system can be approved. Hiring a qualified electrician is essential for ensuring that electrical work is done safely and correctly. A qualified electrician has the knowledge, skills, and experience to properly design, install, and maintain electrical systems. They are also familiar with the electrical codes and standards that apply to the work being performed. When hiring an electrician, it's important to check their qualifications and to make sure that they are licensed and insured. You should also ask for references and check their reputation with previous customers. A qualified electrician can help you to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Do not perform electrical work yourself unless you are a qualified electrician.